Let's go ahead and get started. So we're given that DE is parallel to AB, angle ACB, so this angle right here, right in the middle, is equal to 65 degrees. Angle ACD is equal to 72 degrees. We want to find angle A and angle B. So to get started, first off, we know that these lines are parallel, and that's very important information. So jumping back to Unit 2, we dealt with parallel lines and transversals. So if these lines are parallel, that would make AC a transversal line. Oops. And if AC is a transversal line, then I have alternate interior angles because they're on opposite sides of my transversal and they're inside the parallel lines. So therefore, angle A and 72 degrees are going to be the same exact angle. So angle A is 72 degrees. Now, to find out what angle B is, well, first off, I have this straight line here. And I know in a straight line, there's 180 degrees total. So I can do 180 degrees minus 65 degrees minus 72 degrees. That will leave me with angle BCE. Well, angle BCE and angle B are also alternate interior angles, and those must be congruent. So if angle BCE is 43 degrees, then angle B is also 43 degrees. And at this point, this problem is finished. All right, so keep this in mind. We will be using this for a proof in just a few minutes. But today, we are covering 4.1 triangle application problems. Our learning target is I can apply theorems about interior angles, exterior angles, and midlines of triangles. Let's go ahead and jump right in. So, the first theorem that we have is the sum of the measures of three angles of a triangle is 180 degrees. That's something that we've known and we've talked about in the past, but today we're actually going to be proving this. So again, as long as we know that there's three angles in a triangle, and if we add all those angles together, it will equal 180. So, let's prove that right now. We're given triangle ABC. We want to prove that angle A plus angle B plus angle C is equal to 180 degrees. So first off, we start out with our given. Now, from here, we're going to make a line that will make this triangle look very similar to our triangle that we did in our warm-up. So we're going to create line DE. And line DE is going to be drawn such that it goes through point B and is parallel to line AC. Now the reason that we can do this is the parallel postulate. We talked about this a couple weeks back. The parallel postulate says that if I have a line and a point that is not on that line, then there's only one other line that will go through that point and still be parallel to the original line. So therefore, that's why we can create this line, the parallel postulate. Now that we have that line created, we can go ahead and label these as angle 1, 2, and 3. When we do that, we now can create angle relationships. So the relationship between angle A and angle 1 is again alternate interior angles. They're on opposite sides of our transversal AB, and they're inside our parallel lines. So therefore, angle A is congruent to angle 1. And the reason that we can say that is because they're alternate interior angles. And if we have parallel lines, that would imply that alternate interior angles are congruent. Now I can say the same thing with angle C and angle 3. So angle C is congruent to angle 3. For the same exact reason, parallel lines imply alternate interior angles are congruent. Then lastly, angle B. Well, angle B is at the same spot as angle 2. So I can say that angle B is congruent to angle 2. And the reason I can say that is, well, they're the same angle. So that would be by the reflexive property. From here, well, this is a straight line. And I know that the sum of the angles that form a straight line is 180 degrees. So I can say angle 1 plus angle 2 plus angle 3 equals 180. And the reason I can say that is a straight line has 180 degrees. Well, let's see. Angle A is equal to angle 1. They're the same. Angle C is the same as angle 3, and angle B is the same as angle 2. So I can now say that angle A plus angle B plus angle C equals 180 degrees. And all I did was I plugged in angle A for angle 1, or another word for plugging in is substitution. So I used the substitution property. And with that, this proof is now finished. So now we know anytime that we have a triangle, there's only 180 degrees in it. And this is the proof that allows us to say that. All right. Now, how have we defined the term exterior in the past? Well, we just dealt with interior angles, alternate interior angles. What about exterior? Well, we used to say that exterior was outside the parallel lines. So when we are talking about exterior for a triangle, we're talking about the outside of the triangle. So exterior is just going to mean outside for us. So I have this triangle here, and interior angles are inside the triangle. Exterior angles are formed outside the triangle. And again, these are formed because we can use auxiliary lines to extend the legs of these triangles. We can say, okay, let's just stretch out this leg, and now we have an exterior angle. And we're going to see these quite often. So let's have a formal definition as well. An exterior angle of a polygon is an angle that is adjacent to and supplementary to an interior angle of the polygon. So adjacent just means next to, and supplementary we know means that they add to be 180 degrees. So as we can see, an exterior angle will be outside, and it's supplementary to the angle that's right inside of it, the interior angle right next to it. Now, along with that, just so that we can see it a little bit better, they form a straight line, so we know that the sums will be 180 degrees. Now, again, this angle right here in the middle, let me go ahead and just put this back. This angle is called the interior angle. So this is our interior angle. Now the other two angles are also interior, but they have a more specific name. These other two angles that are not right next to, they're not adjacent to our exterior angle, those are called remote interior angles. Remote meaning that they're isolated, they're by themselves. So they're remote interior angles. And remote interior angles will have some special properties that we'll talk about in just a minute. But again, knowing each of these terms, knowing where they're located in triangles and trapezoids and various figures is very important and very useful for us. All right, let's go ahead and see this next theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. Meaning, if I add my two remote interior angles together, it will equal the exterior angle. And the reason that this works is because, well, the sum of a straight angle is 180 degrees, and the sums of the interior of a triangle, those angles are also equal to 180 degrees. So that is what allows this to work. So angle D plus angle E is equal to our exterior angle, angle 1. Go ahead and pause the video if you need to finish catching up on these, and then we'll continue on. So the last theorem that we're going to talk about today is the midline theorem. The midline theorem states a segment joining the two midpoints, so I have two midpoints, H and M here. The segment that's joining those together is parallel to the third side. So it's HM is going to be parallel to JK, and also HM is going to be 1/2 of JK's length. So again, we have the midpoints here that we can see, and then it's parallel to the side that it does not intersect. So these two segments will always be parallel whenever we have a midline. Now, again, they're midpoints because we can see that it's splitting the segments into two equal parts, which allows us to say that this is the midline. Now, from here, its length is 1/2 the length of the third side. So if my third side is 8, that would mean that my midline is 4. It's half of it. And also that works the other way as well. If I were to say that my midline is 6, well then JK would be double that length. So JK would be 12 in that case. So it does work both ways in terms of midline. If I'm given the midline, I can find that other side, the side that it's parallel to. And if I'm given the side that's parallel to, then I should be able to find the midline as well. All right, so again, very important that you know that's known as the midline theorem, because when it says prove the midline theorem, we need to know what we're proving. So some abstract thinking before we actually prove that. How can I create another triangle that would be congruent to a triangle GHM? And can we actually make a triangle like that? Well, yes, we can make a triangle like this. And how we would do that is we would find another midpoint. So where would you put that triangle in the diagram? Well, I would put the triangle where I can find the midpoint. So I use the midpoint of JK to create another midline. So I find the midpoint of JK. I'm just going to call it point N, and it's going to change slightly, so I might as well just erase that. So I'm going to call it point N. And we can see that this creates a lot of other congruent triangles. So since the midline is at the midpoint, and all these are midpoints here, H, N, and M are all midpoints, that means that splitting it into two congruent parts. Further, I know that the midline is half the length of the other side. So the midline would be congruent to Jn and Nk. Hn would be congruent to Gm and Mk. And Mn would be congruent to Gh and Hj. So again, the midline allows us to create a lot of different congruent triangles. And of course, all these triangles are congruent by side, side, side. So let's go ahead and try and prove this. Prove the midline theorem. We're given that H is the midpoint of Gj and M is the midpoint of Gk. Now, if we're proving the midline theorem, we need to hit two goals. First, we need to prove that HM is parallel to JK. So these two lines need to be parallel. And then HM needs to be half of JK. If we can prove all that, then we're good to go. So to start with that, I'm going to start by saying that I'm going to go ahead and state that I'm just extending HM out so that MP and HM, so that MP and HM are congruent. So extend line HM through point M such that HM is congruent to MP. The reason that we can say that is, well, we're drawing an auxiliary line, so 2 points determine the segment. And that's any time that you draw an auxiliary line. From here, we see that we have vertical angles. So my two vertical angles would be angle GMH and angle PMK. So I can say that those two angles are congruent. Angle GMH is congruent to angle PMK because vertical angles are congruent. Now from here, again, we know that M is the midpoint. So I can say that GM is congruent to MK. So GM is congruent to MK. And the reason that we can say that is because I know that M is the midpoint, and a midpoint will divide a segment in two. At this point, I can prove that these two triangles, triangle GMH and triangle KMP, these two triangles are congruent. And the reason that they would be congruent is because we have side, angle, side. So triangle GMH is congruent to triangle KMP by side, angle, side. Now, if that's true, I should now be able to focus in on the corresponding parts. So the first corresponding part that I'm going to focus in on are the angles. I'm going to say that angle G is congruent to angle PKM. And the reason that we can say that is because we know that corresponding parts of congruent triangles are congruent. So we can say CPCTC. Now, if I look at this, GK is now a transversal line. If these two angles are congruent and GK is transversal, and I'm focusing on now line GJ and line PK. Well, line GJ will be parallel to line PK, and the reason that they will be parallel is because we have alternate interior angles. And if the alternate interior angles are congruent, that would imply that we have parallel lines. So now we know that these two lines will be parallel because alternate interior angles are congruent. Further, I can also say that PK is congruent to GH. PK is congruent to GH. And the reason that we can say that is it goes back to CPCTC. These two triangles are congruent, so all the corresponding parts are congruent. So the corresponding parts of congruent triangles are congruent. Along with that, H is a midpoint from our given information. So therefore, GH and HJ should also be congruent to each other. So GH is congruent to HJ, and the reason is the same as number 3. A midpoint divides a segment in two. So that's why we can say that those two segments are congruent. Now, if PK is congruent to GH, and GH is congruent to HJ, I should be able to just say that PK is congruent to HJ. And the reason that we can say that PK is congruent to HJ is because I'm just skipping over GH. So that would be by the transitive property. Now at this point, we're going to go into some things that you guys haven't learned yet because it's dealing with parallelograms. So The first thing I'm going to go ahead and say is that PKJH is a parallelogram. And the reason that we can say that is because opposite sides are congruent and parallel. And if opposite sides are congruent and parallel of a figure, that would mean that's a parallelogram by definition. So, we now have a parallelogram. One of the key things about parallelograms is that opposite sides are parallel. So I can say that HP is parallel to JK. And again, opposite sides of a parallelogram are parallel. That's the definition of a parallelogram. It's in the name, parallel. So, I know that opposite sides are parallel, and that's one of our goals. We hit our first goal. Now we need to reach our second goal. HM is equal to 1/2 of JK. So the next thing that I can state is that HP is congruent to JK. And that goes back to another property of parallelograms, that opposite sides of parallelograms are congruent. From here, if these two segments are congruent to each other, the full segments, and I know HM is equal to MP, then I can therefore say that HM is equal to 1/2 of HP. Because again, HM is 1/2 of HP because M is the midpoint there. And that also goes back to what we started with. Now from here, I know that HP is congruent to JK. So if that's the case, I should be able to say that HM is equal to 1/2 of JK. And again, the reason that we can say number 13, HM is congruent to MP from our original number 1. So therefore, HM is equal to 1/2 of HP. So at this point, I plug in JK for HP, and I have HM is equal to 1/2 of JK. Therefore, the reason that we can say that is we just substituted it in. So therefore, I just took JK and plugged it in for HP. With that, the midline proof is now proven because we have reached both of our goals. Awesome. So, next up, this problem is very important that you guys get down. If one of the angles of a triangle is 80 degrees, find the measure of the angles formed by the bisector of the other two angles. So, again, very important that you guys know this one. It will show up again. So, what they're asking for here, find the measure of the angles formed by the bisector of the other two angles. What they want us to find is to find the measure of angle BEC. Whoops. Didn't want to do that, but oh well. So we want to find the measure of angle BEC. That's what this question is actually asking for. So we want to find this angle right here. Now, in order to do that, we're going to go ahead and focus on our big triangle to get started, ABC. So I know that the sum of all these angles is 180, so I have x plus y plus y plus 80 equals 180 degrees. Now from here, I'm just going to go ahead and simplify. I combine my like terms, 2x plus 2y, and then I subtract the 80 from both sides, giving me equals 100. Simplifying it down further, I divide both sides by 2, and we get x plus y equals 50. So I know that x plus y is equal to 50. Now from here, I'm going to focus on triangle BEC. So I know that triangle BEC's angle sum is x plus y plus the measure of angle BEC is equal to 180. But I know that x plus y is equal to 50. So I see x plus y over here. I'm going to replace x plus y with 50. So I now have 50 plus the measure of angle BEC equals 180. Lastly, we just solve for the measure of angle BEC by subtracting 50 from both sides, and we get the measure of angle BEC is equal to 130 degrees. And that's our final answer. We finally hit our goal. Now again, you guys are going to see this in the future. The only thing that will probably change is the number right up here, the 80. So keep in mind the process of actually doing this problem. Find the measure of all your angles for the big triangle, simplify as much as possible, and then plug back in for your smaller triangle. All right, next up, given angle ORS is equal to 4x plus 6, angle P is equal to x plus 24, and angle O is equal to 2x plus 4. Find the measure of angle O. So we have two remote interior angles and an exterior angle. If I add angle O and angle P, it will equal angle ORS by the remote exterior angle theorem. So, just plugging in 4x plus 6, the exterior angle is equal to the sum of our interior angles. Combining like terms, 2x plus x equals 3x. 4 plus 24 is 28. Subtracting 3x from both sides, I get x plus 6 equals 28. Subtracting 6 from both sides, we get x equals 22. Now again, we're trying to find the measure of angle O. So I plug 22 back in for angle O, and we have 2 times 22 plus 4 is equal to the measure of angle O. Well, 2 times 22 is 44, plus 4 is 48. So the measure of angle O is 48 degrees, and the value of x is 22. Our last problem of the day, and the diagram is marked. If wx is equal to 18, find AW. So looking at this, A and Y are both, sorry, I said AW, this should be find AY. A and Y are both midpoints, and we can see that because they're splitting the segments in two. So therefore, if wx is equal to 18, that means that AY should be half of it, because AY is the midline. So therefore, AY is equal to 1/2 of wx, AY is equal to 1/2 of 18, AY is equal to 9 units. All right, so that is it for today's lesson. You guys do have homework. If you guys have any questions on the video or any questions on any of the problems that we've done, please let me know, but have a great rest of your day, guys. Thank you for watching.